Hello friends, so today we are going to discuss questions, and these questions are from the session that was held on 22nd morning as well as evening. So we are going to discuss questions from JEE Mains, and that was held on 22nd, both morning as well as evening session. And please remember, these are only the memory based questions. And we are going to discuss questions from the physics part. Okay. So in the first question, it states that two disks have same amount of inertia about the center of axis, that is perpendicular to their plane, their thickness are T1 and T2 respectively. They are made of material with the same density. Given that the ratio of the radii is 1:2, find the ratio of T1 to T2. And we are given that we have two disks, and we can use our moment of inertia formula. So you can say that our moment of inertia of the disk is, let us suppose, I, then this I will be equal to 1/2 mr square, and m is the mass of the disk. And this mass we can write it as our density multiplied by pi r square, and T is our thickness. Therefore we can substitute it in the moment of inertia. So we get our moment of inertia I will be equal to 1/2, and this comes as rho pi r square T, and this comes as our r square. Therefore we can write this as our 1/2 rho pi r4 multiplied by T. And it is given that we have two disks and they have the same moment of inertia. Therefore we can write that both disks have same moment of inertia. Therefore we can write this general formula into two parts. First will be our half rho pi r1 4 T1 is equal to 1/2 rho pi r2 4, and this comes as our T2. Therefore this half rho pi cancels out. From here we get that our T1 upon T2 will be equal to R2 upon R1 whole raised to power 4. And we are already given, so we get this as T1 upon T2 is equal to 2 raised to power 4, which comes as 16. Therefore, the ratio T1 is to T2 is 16 is to 1. That was our first question. And second question, it states that in a series RL circuit connected to a battery, the battery voltage is 10 volt, the resistance is R 10 ohm and the inductance is 10 millihenry. Find the energy stored in inductor at the instant when the current reaches 1 upon E times the maximum value of the current. So we have a series combination of R and L. And we are connected to a battery, and this is a resistance inductor. Resistance is about 10 ohm and this is about 10 millihenry, and the supply voltage is our 10 volt, and we have to find out when the current reaches 1 upon E times the maximum value of the current. And in general, we can write the growth equation of the current in a RL circuit. So we can say the current grows in RL circuit, and we can write this as our I of t will be equal to our I naught, that is maximum value of the current, 1 minus E, and this comes as minus t upon tau. And this I naught is a maximum value of the current, or we can also call it as a steady state current. So we can say that I naught is our steady state current, or we can also call it as a maximum value of the current. And the steady state value of the current, okay, means when time is infinity, inductor is going to act as a short circuit. Therefore, I naught will be equal to 1 V upon R, and this comes as 10 upon 10, giving us 1 ampere. So this is a maximum value of the current, and tau is our time constant. And time constant for our RL series circuit is equal to L upon R. So this comes as 0.01 upon 10, which gives us 1 millisecond. And we have to find out the instant when the current is 1 upon E times the maximum value of the current. So you can say the instant when the current, that is our I, is equal to 1 upon E, the maximum value of the current, and maximum value of the current is our 1, so this comes as a 1 upon E. Therefore, we substitute it in this equation, this equation 1. So you can say from equation 1, we get this as 1 upon E is equal to, and I naught is our 1, so this comes 1 minus E, and this is our t upon tau. Now it is only calculation part, so we can write this as e raised to power minus t upon tau will be equal to our 1 minus 1 upon E, and we can write this as E minus 1 upon E. Therefore, you can say minus T upon tau is equal to our natural log of E minus 1 upon E. And this comes minus T upon tau is equal to natural log of E minus 1 minus natural log of E. So this comes as a natural log of E minus 1 minus 1. Therefore, we get that our T is equal to our tau 1 minus natural log E minus 1. And we are supposed to find out the energy. There is no need to solve it further because it will be you can say easily solved in the energy part. So you can say that our energy stored in the inductor, that is our U, is equal to over half Li square. And we already know that our U is equal to, this comes as a half, and our L inductor is given as 0.01 times this I will be equal to the maximum value and divided by E and its whole square. So this comes as our 0.005 multiplied by 1 upon E square. And therefore you can say that this our U, energy stored, will be approximately equal to 0.677 millijoules. Next question. It states that a particle is projected at an angle of 60 with the horizontal with initial speed u. When the projectile makes angle of 45 degree the horizontal, its speed becomes 20 square root of 2 meter per second. Find the value of u in meter per second. This is quite easy, and basically it's a projectile motion, and we know that the horizontal component of projectile is same throughout. So let us draw approximate figure, and so it is given that a projectile is launched at an angle of 60 degree, and let us suppose it is launched at a velocity u and it is having an angle of 60. After some time, suppose it reaches here, and at this particular instant its velocity is suppose our v, and here it is making an angle of 45 degree. So this is the basic figure, and we can divide both u as well as v in terms of their components, and we are interested in the horizontal component only. We are not interested in the vertical component. We can say, let us call this as point A and this as point B. So you can say at A you can write horizontal component, let us call this as u of x. So we are having that u of x will be equal to u cos of 60, and then we come to our at b, and once again we are going to write their horizontal component, and let us call this as v of x will be equal to v cos of 45, and we already know that these two will be same. So you can say that our u of x will be equal to v of x, which gives us u cos of 60 will be equal to v cos of 45, and v is already known to us, that is 20 square root 2. So 20 square root 2 multiplied by 1 upon square root 2. Square root 2 square root cancel out, okay? And we get here as cos of 60, cos 60, so this will be giving us u will be equal to, this will be 2 and this will be 40 meter per second. Next question. It is given that three coils C1, C2 and C3 are identical in shape, likely circular loops or short solenoid coplanar coils placed along a straight line. Each carries same magnitude of current I with the direction shown. Okay, we can just draw the figure later on, but here it is explained. For C1 it is upward, C2 is downward, C3 is also downward. The coils are arranged along a straight line, and if C2 is released, it is free to move, while C1 and C2 are presumably fixed. Then it will be. So we have to find out what happens to the C2. So we can just draw the figure. So we have three coils. And all these coils are coaxial. And so this is C1, C2 and C3, and current is given to us, it is flowing in upward direction and both are in downward direction. So we know whenever there is a current flowing in the same direction, that is going to give us attraction, and whenever there is a current in opposite direction, it is going to give us repulsion. So same thing we are going to use it here. So we know that our same direction gives us attraction, and opposite direction results in the repulsion. And so it means that our C1 and C2, they are in opposite direction, but C2 and C3 are in same direction. So it means that our C1 and C2, they are opposite current, so this will be resulting in repulsion. And our C2 and C3, the current is in same direction, so this is going to result in attraction, and only C2 is free to move, so C1 is going to repel and C3 is going to attract. So both forces are in same direction towards C3. Therefore we can say that both forces are in same direction towards C3. Towards C3. So it means it will be moving towards C3. Next question. It states that in a meter bridge experiment, the null point for two resistances R1 and R2 is obtained at 40 cm from the end where R1 is connected. That is, the bridge wire segment is 40 cm for R1 side and 60 cm for R2 side. And when the resistance of 16 ohm is connected in parallel with R2, the new null point shifts to 50 cm from the same end. Find the value of R1 and R2. So the figure is given to us. So we are given this as our R1, and this is our R2, and this is the wire on which we are going to write the null point, and somewhere here, so it is given as our 40 cm. This is the R1 and this is R2, and there will be a battery source connected here. And basically this null point, or we can say the bridge, meter bridge at the null point is resulting in the basically a balanced bridge, balanced meter bridge rather. Therefore, we can say that in a meter bridge, at balance, that is our nothing but our null point, we can write that our R1 upon R2 will be equal to L1 upon L2. R1 upon R2 is equal to L1 upon L2. Or in general, we can write it as L1 will be the length on the R1 side and L2 will be the length on our R2 side. So this is the length on R1 side divided by length on R2 side. So we have two cases, so let us discuss both cases one by one. So we have our case number 1, null point at 40 centimeter. Null point is given as 40 centimeter, okay, and this is from our R1 end. Therefore, we can say that L1 will be equal to 40 and our L2 will be equal to 60 centimeters, because the total wire length is our 100 centimeter. Therefore, we can say that our R1 upon R2 will be equal to 40 upon 60, giving us 2 upon 3. And you can say that R1 is equal to 2 by 3 times R2. Let us call this equation number 1. Now we come to our case 2. And in case 2, it is given that 16 ohm resistance is connected in parallel with R2. So we have 16 ohm resistance and that is connected in parallel with R2. So let's find out the equivalent resistance, and let us call this as our R prime. R prime will be equal to our 16 R2 plus 16 R2, and null point is given as a 50 centimeter. So we are given that the null point is our 50 centimeter, and this is from our R1 end. So L1 will be equal to 50 and our L2 will be also equal to 50. And please remember, now this our L1 is our R1, but L2 in this case is our, let us call this as R2, is our R2 prime. Therefore we can write that our R1 upon R2 prime will be equal to 50 upon 50, which is equal to 1. Therefore we can say that our R1 is equal to our R2 prime, and R2 prime is our 16 R2 and 16 plus R2, and this is our equation number 2. So we can say that from equation 1 and 2, equation 1 and equation 2, and so we simply substitute value of R1 and we get this as our 2 by 3 times R2 is equal to 16 times R2 and 16 plus R2, and so this is quite easy to solve. So this will be giving us that value of R2 will be equal to our 8 ohm, and our R1 is 2 by 3 times 8, which comes as 16 upon 3. So we got value of R2 as well as our R1, which was required. Next question. So in this question, match the physical quantities of list 1 with their correct dimensional formula in list 2. So we are given physical quantities. First one is spring constant. Spring constant is our K, and for that we can use that F is equal to our Kx. Therefore we can say that our K will be equal to force divided by our X, and this force is our ml t minus 2, X is our length. So therefore we get that our K will be equal to ml0 and t minus 2. So ml0 t minus 2, so we get that A is equal to our ml0 2 second. Now we come to our thermal conductivity. Thermal conductivity, and for thermal conductivity we can use the formula that Q is equal to our thermal conductivity is also represented by A, so this comes as K times A, and we have this as delta T upon D. Therefore we can write that we require our K will be equal to, this comes as our Q multiplied by D, and this is our A delta T and T. So we simply substitute. Q is our heat, this is ml square T minus 2, and D is nothing but our type of length, so we have L and A is our area, so this will be L square, and T is our temperature, that will be in Kelvin, and T is our time. So we get that this will be equal to, we have this as ml T minus 3 K minus 1. So we have ml T minus 3, so B gives us 4th. Next is our Boltzmann constant. Boltzmann constant, and for that we can use our you can say energy upon temperature. So we can say our Boltzmann constant will be equal to our energy upon temperature. So this gives us that our Kb energy is our ml2 T minus 2, and temperature is Kelvin. So this gives us our ml square T minus 2 K minus 1. So we have option number 1. So this is C, matches option number 1. So obviously last one automatically is our inductance, and inductance is going to match our option number 3. That is only thing that is left. So D gives us 3. Next question. Okay, so please remember these are all memory based questions. Okay, so there might be something here and there. Okay, data might be missing, or sometimes the question frame is little bit different, but you get the feel what kind of basic understanding of the question. Okay, that's the most important part. And this question, 4 masses are placed at the corners, 4 kg, 3 kg, 2 kg and 1 kg. The 1 kg is at the center, but actually the test mass is 1 kg at the center and other masses are fixed at the corner. The figure shows masses at the corner as 4, 3, 2, 1 kg with 1 kg mass at the center experiencing gravitational force F1 due to 4 corner masses. When 4 meter and 3 meter masses are interchanged, 4m, 3m masses are interchanged, the force at the center becomes F2. So it's given ratio of F1 by F2 is 2 square root of alpha. We have to find out value of alpha. So here this question is not clear, but basic. We are given that we have 4 masses, okay, and each are placed at the corner. So we have 4 masses and their positions are given to us, 4m, 3m, and this is 2m, and this is m. And at the center there is another mass, and we have to find out how the force is going to change when there is interchange of mass. So first of all, the distance of each mass from the center is same. Okay. So it means that the force will be, because we can say the force magnitude scale only with the corner masses, and the angle will be our 45 degree. So you can say that the common factor which will be associated with all these masses we can just ignore. So we are going to have a common factor because the distance between the masses is same, and along with this the angle is also same. Therefore we can say that common factor that will be associated is our capital G, and this is 2d square and y square root 2. So this is our common factor throughout all the, you can say, calculation part. And now let us find out what are the things that are given to us. So in the first part, let us take our case number 1, and for case number 1, because it is one second. Okay, so for case number 1 we can say that our net force in our x direction will be equal to 0, and similarly we can write that the net force in our y direction will be only proportional to our 4 plus 3 minus 2 and minus 1, and that will be equal to 4. Therefore we can say that our F1 will be equal to 2g, and this comes as d square square root of 2. Now it is given that 4 kg and 3 kg are interchanged. So we have our case 2. We are given that 4 kg and 3 kg are interchanged. Therefore we can write that the net in x direction will be proportional to minus 3 plus 4 plus 2 and minus 1, which will be equal to 2. Whereas our net y is unchanged, which will be equal to our 4. Therefore we can write that our F2 will be equal to square root of 5 times g divided by d square and square root of 2, and we are supposed to find the ratio. So we get our F1 upon F2 is equal to 2 square root of 5, which is given to us as 2 square root of alpha. So we get that value of alpha is equal to 5. Next question. It states that 6 rods of identical length and identical cross section area are connected between 100 degrees centigrade and 40 degrees centigrade as shown in the figure. Their thermal conductivities are marked on the diagram in terms of K. Find the temperature difference between point A and point B, that is TA minus TB, and basic figure is given to us. So this is the basic figure, and this extreme is given as 100 degrees centigrade, and this is our 40 degrees centigrade. This point is given as A, this point is given as B, and the conductivities with respect to, this is 3K, this is K, this is K, this is also 3K, 3K and K. So this is the basic figure that is given to us, and so we can find out the equivalent thermal resistances for each part. So let us call this as our A prime, and this point as a B prime, and this is C, and this is our C prime. So first of all, we find out thermal conductivity between A prime and A. Sorry, not thermal conductivity, but thermal resistances. So we have thermal resistances, and from our A prime to A, and we are given that its conductivity is our 3K. So let us call this our R1, which will be equal to 1 upon 3K. And then we are between B and B prime. Here our conductivity, it is given as our K. So we can say this is our R2, which will be equal to 1 upon K. And between A and B, we are having basically parallel combination. So let us calculate it separately. So you can say between A and B, we are having two parallel paths. First parallel path is our ACB, and they are in series. So we can say this will be equal to our K plus K, and let us call this as our R3, and we get this as 1 upon K plus 1 upon K, which gives us 2 upon K. And the second path is our lower one, and that is our AC prime B, which is our 3K plus 3K. Let us call this our R4, which will be equal to 1 upon 3K plus 3K, giving us 2 upon 3K. Now they are in parallel, therefore we can write 1 upon RAB will be equal to 1 upon R3 plus 1 upon R4. So we get this as 1 upon 2 upon K plus 1 upon 2 upon 3K. So this gives us that our RAB will be equal to 1 upon 2K. Now we can easily find out the total resistance between A and B. Sorry, not A and B, but A prime and B prime. You can say between A prime and B prime, let us call this as R total, that will be equal to our R1 plus RAB plus R2. So we get our R total will be equal to 3K plus 1 upon 2K plus 1 upon K, and this comes as our 11.6K. So this is our total thermal resistance. Okay. And 1 second. Okay, so we need to find out our temperature difference. Okay. From here, now we can easily find out the heat current. I thought it is complete, but we have to find out something else. So you can say that we have our heat current, that is H will be equal to change in temperature divided by total resistance, and the difference in temperature is 140, so this comes as 60, and 11 upon 6K. So this gives us 360K upon 11. Now we can use that from A prime to A there is a temperature, so we can say that our from 100 degrees to our A, and we can write that our delta T from 100 to our A will be equal to H times R1. So this comes as our H is our 360K upon 11 multiplied by R1 1 upon 3K. This comes as 120 upon 11. Therefore, our TA will be equal to 100 minus 120 upon 11, which will be giving us 980 and approximately 89.09 degree centigrade. Similarly, we come to our from B to 40 degree centigrade. Same process, delta T will be equal to from B to 40 equal to H times R2, and that comes over 360 K 11 1 upon K, which gives us 360 upon 11. Therefore, temperature at B will be equal to 40 plus 360 upon 11, which is our 811, approximately 72.73 degree centigrade. Okay. So now we come to our temperature difference. That is our TA minus TB will be equal to our 980 minus 811, approximately coming as 16.36 degree centigrade. Next question. It states that the electric field in the region is given by the equation where x and y are in meters. If the electric potential at 3, 4 is plus 500 volt, then the electric potential at the origin is given by. So we are given the equation, and so we are given that electric field is equal to over 6I plus 8yj, and we want to find out the potential at the origin. This is our requirement. So we can use the relationship between our E and V. So we know that our electric field is given as a divergence of our potential, and in terms of our integral form we can write it, which we have generally studied, is our V at a R2 minus V at R1 is equal to minus integral of our R1 to R2 V dot dl. This is a relationship between our and our the path will be from our 3, 4, and it will be going towards our origin. Okay. So we can just say that it is a straight line, convenient path. So we can say that for a straight line path, we can write that our x is our 3t and y is our 4t, and our t is from 1 to 0. Therefore, we can write that our dx will be equal to 3 dt and our dy is equal to 4 dt, and we need the dot product of E and dl. We can see E dot dl will be equal to the x component plus the y component. So this comes as our 6x dx plus 8y and dy, and we already know value of our x and value of our dx, value of y as well as value of dy. So we substitute them. So we get this as our e after dl will be equal to, here we substitute value of x, so this comes as 6 times 3t and dx is 3 dt plus 8 times 4t and 4 times dt. So we get this as our 54 plus 128, so that will be equal to 182t and dt. Now we can just integrate it. So we get for our v00 minus v at 34 will be equal to minus goes from 1 to 0, 182 t and dt, and this is our minus, this will be coming as t square, 182 divided by 2 times t square, and this will be our 182 divided by 2 giving us 91 minus of 91, so this will be our plus of 91. Therefore we can write that our origin will be equal to v comma 34 plus 91, which is given to us as a 500 plus 91 is equal to 591 volts. Next question. For which of the following input combination A, B, C, D will the diode be forward biased? So basically we are given a logic gate circuit. So draw it. This is input A, this is input B, and we are having our C and D, and here we are having a diode connection. Sorry, this is the diode. And we have to say that the diode is forward bias. So forward bias, we know that this is our P and this is our N terminal. So our P should be a larger potential as compared to N. Okay, that is the condition. So we are having this A and this is a 2 input NOR gate. So this will be giving us our A bar. Similarly, this will be giving us B bar. Then we are having 2 input, and we can write this will be equal to our A bar plus B bar and whole bar, which can be written as our we can use the theorem, and this can be segregated as A bar dot B bar, which will be our A times B. Okay. So this is basically our 2 input AND gate. And on the lower side we are having our two input NOR gate, so we get this as a C plus D and bar, and we want that for forward bias our P should be greater than our N, or we can say that our A dot B should be greater than C plus D bar. So we can check it one by one, and so we can say that our A dot B should be equal to 1, because the highest value in a logic is only 1, and that is only possible if our A is also equal to 1 and B is also equal to 1. See, the our AND gate logic is there. Okay. So our P should be greater than N, and we can say A dot B should be greater than C plus D bar. Okay. And we have to remember that this is our diode, and we are having this is a positive and this is a P type and N type. So here it has to be 1 and this is to be equal to 0. Under this condition only P will be greater than our N. And for our C plus D, so our C plus D bar should be equal to 0. That is only possible if C plus D is equal to 1. And so which is true for all the condition except our value of C, D, this cannot be equal to 0. So we have to keep this in mind, because if C plus D is equal to 1, so from here we can say that if this value is equal to 1, then our C plus D bar will be equal to 0, okay, which we want. But if C or D is equal to 0, both are equal to 0, then our this C plus D will be equal to 0 plus 0, which is 0, and with bar this will be equal to 1, so which is not required. So we have to keep this in mind, and therefore we can make various combination of that, and we know that value of A is equal to 1 and value of B is equal to 1. This is always fixed. But for our C plus D is equal to 1, so we can just write that if this is 0, this is 1, then C plus D will be still equal to 1. And if C is 1, D is 0, their summation still equal to 1. And if both are equal to 1, their summation is equal to 1. So we can have multiple combination of this A, B, C, D. So we can write this as our A, B, C and D. A and B will be always fixed, they cannot be changed. So this will be AB is always fixed. C and D we can just change. So we can write this as our 0, 1, and once again A and B are fixed, so this will be our 1, 0, and finally we are having A and B are fixed and C and D will be equal to 1 and 1. So for all these conditions, okay, we are going to get that our diode is forward bias. So this was a little bit tricky, okay, but you can say with the logic you can easily sort it out. Next question. It states that a parallel beam is incident on a convex lens of a material refractive index 1.5. The beam converges at a distance x centimeter from the lens. That is, x is the focal length f of the lens. The radius of curvature of both the surfaces is 50 centimeter. Find the value of x. So beam converges at a distance x. So converges basically is nothing but our focal length. And for that we can use the lens maker's formula. And that lens maker formula, it gives us 1 upon f is equal to mu minus 1 and radius of curvature of first and second. And so ray of light travels from our left to right. Therefore our R1 will be equal to plus 50 and R1 will be equal to plus 50 and R2 will be equal to our minus 50. And therefore we can, mu is already known to us, so this is 1 upon f is equal to 1.5 minus 1 and this comes as 1 upon 50 plus 1 upon 50. So we get this is equal to 1 upon 50. Therefore we get our focal length is equal to 50, and it is given in the question that the beam converges, so convergence is always at the focal length. Therefore we can say this is our value of our x. Next question. It states that a pendulum has a bob of mass m and charge q. In its equilibrium, in the presence of a uniform horizontal electric field E, the thread makes an angle of theta with the vertical. The tension in the thread is. So basic figure is given to us. So we are given that this is the vertical and we are having a pendulum which is having a charge here. This charge is about q, mass is given as m. The electric field is from left to right. So this is the value of electric field and this angle is given as theta. Now we have to find out the tension. So we can just, let us suppose this is tension T and we can divide this into two components. So this will be theta, we are going to get T cos of theta and T sin of theta, and in this particular position the bob will be in equilibrium. Therefore we can say that component balance and first is our vertical and vertical gives us T cos of theta is equal to over mg, and then we have a horizontal our T sin of theta is equal to force due to electric field. So this gives us that our tangent of theta will be equal to QE upon mg, and we are interested in the magnitude. So since this, let me draw it, so we are having our mg and then there is a force Q times E and they are both at 90 degree and our tension is somewhere here. So the resultant this is at 90 degree, therefore you can say its resultant will be in this direction, that will be equal to our tension T. So you can say that our mg is perpendicular to our QE, therefore we can write tension T will be equal to our mg square plus QE square and it is square root. So this is our magnitude of the tension. Next question. It states that 6-point charges are placed on the circumference of a circle of radius r as shown in the figure. The charges are arranged symmetrically with respect to axis. The electric field at the center of the circle is given by E kq r square multiplied by alpha I plus beta j. Find the value of alpha and beta. So basic figure is given to us. So we have charges that are placed in a circle. So this is the center of the circle. This is your x-axis and this is your y-axis. So charges are here plus q minus q, and here it is plus q. This is also our plus q and this is also plus q. Okay, and so it's everything is symmetrical. Okay, the distance is radius is same. Therefore, we can say, let us call this as our A, B, C, D, E and F. So the electric field, because of this A, will be in this direction, that is our EA, and because of our B will be in this direction, that is our EB, because of C in this direction our EC, and because of D it will be in opposite direction, that is our ED, and E giving us EE, and our F, oh sorry, one second, here it is reverse because it is a negative sign, my mistake. So this in upward direction, this will be our EC, and because of F it will be also in the same direction, that is our EF. So all the electric field are going to balance out each other. Only electric field, that is of EF and EC, are in the same direction. So simply we can add them. And so let me, we are interested only, so here we are going to have our EC, and in the same direction we are going to have our EF, and the angles are given to us. So this angle is our 30. So we can just divide into components, and because their magnitude will be same, so we are going to get that our electric field will be equal to twice K times Q and R square. And in terms of their respective coordinates, we can say that our E will be equal to 2K Q upon R square, and this will be our cos 30 and this will be our sin 30. So we get this as our cos of 30, and this will be minus of I plus sin of 30 and j, and we already know the values. So this will be equal to our, you can just cancel out 2, so this will be kq r square, and this is minus 3i and plus j. So this is our value of our alpha and beta will be equal to minus square root of 3 and beta is equal to 1. Next question. Okay, so it states that 3 identical uniformly charged balls each of charge q are merged together to form a single bigger ball. Assume the charge is conserved uniformly distributed in the bigger ball or throughout its volume depending upon the context. But standard for conducting, it is not part of the question, it was a little bit. So the question was straightforward. The ratio of the electric potential of the bigger ball to that of the smaller is x. Find the value of x cube. So this is not part of the question. Basically it is related with the charge conservation. So we are given that there are 3 identical balls. So this is our charge conservation. So we can say the total charge after merging will be equal to 3q, and we can also find out their volume ratio, or we are interested in the radius ratio. So we can say that our radius of our big sphere cube will be equal to 3 times the radius of our small. Therefore we can write that radius of our big will be equal to, this will be our third root of our small, and we know that our electric potential that is our V is given as kq upon r. So we can write this same formula for the small as well as big. You can say for small, our potential small will be equal to kq upon r, and we can write for big, we can say potential big will be equal to, this is a k, this is our 3q, and radius big. We already know the relationship between the big radius and the small, so this comes as our k 3q, and this comes as our third root times r, which can be written as our 3 2 by 3 kq upon r. Now their ratio is given to us our x. So we are given that the potential because of the big potential of our small is equal to x, and that will be equal to 3 2 by 3. We need to find out our x cube. Therefore we can say that our x cube will be equal to, this is 3 2 by 3 whole cube, giving us 3 square and 9. Next question. Okay. This was same question. It states that find the dimensional expression epsilon naught E divided by T, where epsilon is the permittivity, E is the electric field, and T is the time. So let us start with the electric field. So we know that the electric field is equal to force upon charge, and this we can write as ml T minus 2 upon current multiplied by time t. So this gives us ml t minus 3 and current is our minus 1. Now we need our permittivity. So is our, for that we can use our force is equal to 1 upon 4 pi epsilon naught, and that will equal to our q square upon r square. Therefore we can say that our permittivity will be equal to our q square and fl square. So q we can write our in terms of our I square and time, and force is our, so this I square t square, force is our ml t minus 2 times L square. Therefore we get permittivity will be equal to m minus 1 L minus 3 t raised to power 4 and current square. Sometimes this current is also represented as a ampere in terms of A, and we are going to multiply both. So we need our epsilon times E. So we get this as our m minus 1 L minus 3 t4 current square, multiply the electric field ml t minus 3 and current minus 1, and this gives us m0 L minus 2 t times I, and finally we are going to divide it by time t is equal to m0 L minus 2 ti upon t. So this comes as our L minus 2I, or sometimes it is also written as L minus 2 amperes. And this is nothing but our, if you look closely, this represents nothing but our current density. They are the limit are same. Next question states that in an open organ pipe, the frequency of the third harmonic and sixth harmonic differ by 3200 Hz. The speed of the sound is in the air is 320 meter per second. Find the length of the organ pipe. So we are given the difference between the third and sixth harmonic, and we have to remember this is our open organ pipe. Open organ pipe, and we are given that the difference between our sixth and third is 3200, and we know for the open organ pipe, for our nth harmonic, this will be equal to n times our V divided by 2L, and we can divide this into two parts. F6 minus F3 will be equal to 6 minus 3 V upon 2L. This gives us 3V upon 2L, and now we can just substitute the values. We are given that 3 into 320 velocity of the sound, and this is about 2L is equal to 3200. Therefore from here we get our L is equal to 0.15 meters. This is value of the the length of the organ pipe. Next question, and it states that the energy of the first Balmer line in the hydrogen atom is x joule, then the energy of the second Balmer line in the hydrogen atom is dash joules. Express the answer in terms of x. So we have first Balmer line and second Balmer line. Okay, so we are given that first Balmer, this is E, first Balmer line, which we can also call in terms of alpha. It is for n which goes from 3 to 2, and we are having second and that is sometimes in terms of beta, and in this case the n is from 4 to 2, okay, from the high excuse me. And now we can write the energy emitted by the photon, energy of emitted photon, let us suppose that is our E, then this E we can write in general will be equal to 13.6, and this in electron volt, and the lower one is same for both, so we can write this as 2 square minus 1 upon n square. And now we can divide this into Balmer first and Balmer second energies. You can say that our first Balmer, let us call this as E1, will be equal to 13.6, and this comes as 4, and this is our lower one is our 3, upper one is 3, so this comes at 9, and giving us 13.6 multiplied by 5 on 36, and then it is our second Balmer. We have our E2, same way we get this as our 13.6 times 3 upon 16, and the ratio, okay, X is given to us, so we can write that our E2 upon E1 will be equal to, this is our 3 upon 16 and 5 upon 36, which will be giving us 27 upon 20. Okay. And first Balmer is given as our X, okay, so E1 is our X, therefore we can say that our E2 will be equal to 27 upon 20 times X. Next question. It states that a 20 ohm resistance wire is connected across a 250 volt supply. It is used to generate a heat of which only 1 kilowatt is usable. Find the efficiency of the setup in percentage. So this is indirectly, it is mentioned that amount of usable is only 1 kilowatt. So it is basically our input, some engine, and then it is output. So in terms of efficiency it is given. So it is a beautiful question framed in a different way. And so we are given that we have a resistance of our 20 ohm, and it is connected to a supply voltage of 250, and we are given that the useful is our 1 kilowatt. Okay. So we can write that our input electric power will be equal to V square upon R, and this is our 250 upon 20, which will be giving us 3125 watts, and out of it only 1 kilowatt is useful. Therefore we can say that our efficiency will be equal to power useful divided by input power times 100. This comes as our 1000 1 kilowatt, 3125 multiplied by 100, which comes approximately as 32%. Next question. It states that for the given logic circuit, find the output function in terms of A, B, C, D. Express the final output Y as a Boolean expression. And the basic logic circuit is given to us. Okay, so the first one is our AND, this is A and B. Then there is our NOT, and here we are having our OR. Sorry, it's OR, not NOR. And here it is given to us another AND, and finally there is NOT, and it is our C and D. So we have to find out the expression for our Y. Okay, that's a basic question. So this is our AND, so this will be A dot B, okay, and then is our NOT gate, so this will be our A dot B times NOT, and this we can write as our A complement plus B complement, okay, as per the standard result. And then we have our C and D. This is our OR gate, so this will be C plus D, and they are given at, let us put this over S. So let me sort it out over S. So S will be equal to our A complement B complement and multiply by CD, and our Y is our S complement. Therefore we can write that our Y is our S complement, so this comes as A complement B complement C plus D, and this is our whole complement. And for complement there is a theorem, you can write it as our whole complement will be equal to the summation of individual complements. So same thing we are going to use here also, and so this gives us that our A, B, and on the other side we are going to get this as our C and plus D complement. So it will be coming as AB, and this CD we can write this as our C complement and D complement. One second. Here it is plus, I forgot to write it. This is plus. So final you get that Y is equal to AB plus C bar D bar. So this is our final expression of our logic gate. Next question. It states that in the circuit shown below, switch S is closed at t is equal to 0. Find the reading of the ideal ammeter in amperes just after the switch S is closed, that is at t 0 positive. Let me draw the circuit. So initially the switch was open, and here we are having ammeter, and then there is a voltage supply, and we have inductor initially with the resistance. Here we are having only resistance, and finally we are also having inductor in terms of resistance, and the inductors are given to us a 4 Henry. This is about 9 ohm, 9 ohm, and this is about 4 Henry as well as about 9 ohm, and the supply is given as about 9 volt. So this initially the switch was open, okay. So it means there was no current associated with any of the circuit, especially we are interested in this inductor. So here no current is flowing, here also there is no current. As soon as the switch is closed, we have to remember that there is a wonderful property of the inductor, that it resists all of sudden change. Okay? It means the condition initially will be equal to condition at t positive. Okay? So let me write it here. Okay, so we can say that condition of our inductor at t, I can say this as our my 0 negative, that will be same at t is equal to 0 positive. So it means at 0 negative the current through the inductor both here as well as here was equal to 0. Therefore at t positive the current through the inductor will be also equal to 0. Okay, so this is the property of our inductor. Or in straightforward term we can say that this inductor is going to act as an open circuit, okay, because the current is flowing is equal to 0. Therefore we can say that our inductor is going to act as an open circuit. So if it is acting an open circuit, so this is our ammeter supply, this is open circuit, and this is also our open circuit, and only this is our part of the circuit. So this is given as 9 ohm. So current will be flowing through it and through the resistance. This is open and this is also open circuit. Therefore we can write that our current I, suppose it is flowing as I, that is a reading, you can say reading of the ammeter. We can say that current is equal to, by Ohm's law, V upon R. So this can be 9 upon 9, giving us 1 ampere. So we have to remember this property of our inductor. Our capacitor also has, but in the opposite way. Okay, next question. It states that a frictionless pulley of mass 3m has two blocks m and 2m attached as shown. The system is released from rest. Find the speed of 2m block when it is descended by a distance of 5.4 meters. So basic figure is given to us, and we are having a pulley, and please remember in this case this pulley is not massless, and we are connecting a string, and we are having 2m, and this is our M. So we have to remember that it is saying it is a frictionless pulley. So frictionless basically means that at this particular point where it is going to rotate, there will be no friction. Okay, this is the meaning of frictionless. Okay, but in this particular case we are given that this pulley is having a mass of 3m. Okay, so this is going to play an important part. Okay. So we are going to start from pulley itself. So we are given a pulley and the mass of the pulley is given as 3m. Okay. So we can treat this pulley as a uniform solid disc. Okay, so we can consider this as our uniform solid disc, and we can write it's a moment of inertia is suppose our I, then this will be equal to over 1 by 2 mr square. M we already know, therefore we can write that moment of inertia of the pulley, that is our I, is equal to 1 by 2 3m r square. So this comes as our 3 by 2 mr square. And for block 2m will be moving in the downward direction, and suppose this is the distance it is being moved, that is 5.4, which is our S. Therefore we can say that our distance moved by 2m, distance moved by 2m, let us suppose that is our S, which is 5.4 meters, and initial velocity was equal to 0, and let us assume that there is a tension T1 here and there is tension T2 here. So here we are going to have 2 mg and here we are going to have our mg. So we can write the equation and the acceleration, let us suppose a, and this is equal to a. So we can say for 2m we can write the equation as 2 mg minus t will be equal to 2ma, and we can write for m will be equal to t minus m is equal to m times a. Sorry, this is t1 and t2, my mistake. And there are two tensions, different tension, so we can use rotational dynamics with respect to the pulley. Rotational dynamics, and that is with respect to our pulley. So we can write that T1 minus T2, that's a net force, multiplied by its radius, will be our moment of inertia and our angular acceleration alpha. And we know that our alpha is our linear acceleration times r, and I we already know is our 3 by 2 mr square times a upon r, and here r and r cancels out, therefore we get, and this also cancel here, so we get from here that T1 minus T2 will be equal to 3 by 2 times ma. Let us call this equation number 3. Okay. And we have 3 equations, so we can easily sort it out. So let me write it here. So we are having a T1, that is from equation 1, this will be over 2 mg minus 2 ma, and from equation number 2 we are having mg plus ma. So we can just substitute in equation number 3 and we get our 2 mg minus 2 ma minus of mg plus ma is equal to 3/2 times ma. So this is quite easy. So we get this as mg minus thrice ma, thrice ma is equal to 3/2 times ma, and we can just cancel out our mass throughout. So this will be giving us that our acceleration will be equal to 2/9 times g. Now we can use our we can say kinematics equation. So we can write that our v square is equal to over u square plus 2as. Initially it was at rest, so this is equal to 2 times 2/9, and g we can take as 10 times s is given to us as 5.4. Therefore we can say that our velocity v will be equal to 2 square root of 6 meter per second. This is our velocity. Next question. It states that 5 positive charges, each of charge plus q, are placed at 5 vertices of a regular pentagon. The center of pentagon is O and the distance from the center of each vertex is r. Find the electric potential V, electric field E at the center O due to these 5 charges. Okay. And plus q at each vertex is given to us. So basic figure is given to us. So this is our pentagon. And this is given to us as our r, and all the charges are plus q. And we have to find out the potential at the center O here. So we know that our electric potential is nothing but a scalar quantity, so we can just add it algebraically. So we can say that for point charge, our V will be equal to 1/4 pi epsilon naught q upon r. Therefore, from the given question, you can write for one charge, let us suppose potential is V1. Therefore, we can say that our V1 will be equal to over k q upon r. And from here we can easily find out for 5 charges, let us suppose that is our V will be equal to 5 times V1. So this gives us 5k q upon r. So this is potential because of the 5 charges. And now we come to our electric field. Okay, electric field is our vector, so direction matters. So you can say that field due to one charge that is our E1 will be equal to KQ upon R square. And all are positive charges, so electric field will be pointing away from the charge. So you can say our direction. So we have all positive charges, therefore the electric field points away from the charge. So it means at the center each field vector points from the vertex O outward toward vertex O, and so we are having 4 charges. So this is center O, and okay, let me name it much more easier. This is A, B, C, D and E. Therefore this will be over A and B, and so this will be over B, this will be over C, and this will be over D, and this will be over E. Am I correct? Sorry, 1 second. This is over B and this is over E. Okay. So direction is important in this case. Okay. And as all the charges are equally spaced, therefore we can say the spacing angle will be our 0, 72, 140, 4, 216 and 288, okay, because it has a 5-fold equation geometry. And we can also say that the field vectors are going to have equal magnitude and are symmetrically distributed. You can say our field vectors they have equal magnitude and they are symmetrically distributed. And so the vectors of equal magnitude are placed symmetrically and they are on the point, so their vector sum will be equal to 0. And if required, we can just individually also find out. Okay. So their vector sum will be equal to 0. But that is not much required because they are symmetrically arranged. Okay. So we can say that the vectors of equal magnitude are placed symmetrically around a point their vector sum is 0. So this is our you can say basic concept of, so electric field will be equal to 0, whereas our this potential is our scalar quantity, so simply is our 5 times the potential because of one charge. Next question. Okay, so the same question. It states that in a simple pendulum experiment, the acceleration due to gravity g is determined by measuring its time period. Which of the following plots correctly represents the relationship between the pendulum L and the time period t, or between L upon 1 upon t square? Basically, the graphs are given between L and 1 upon t square. That's so graph is plotted between our L versus 1 upon t square. So this is the graph. So for the basic formula, we know that for small oscillations, the time period is given as 2 pi square root of L upon g, and if we square it, so we get this at t square will be equal to 4 pi square L upon g, and we need 1 upon t square. Okay, so if we rearrange it, we can write this as 1 upon t square will be equal to g 4 pi square and times L, or mathematically we can write this as 1 upon t square is proportional to 1 upon L. Okay, from this equation, because g 4 pi square is our constant, so this gives us the relationship, and this in terms of a general graph we can write this as our y is equal to our kx. Okay, in term, if we want to remove the proportionality, so this relationship can be written as y upon kx. So in this case we have to remember that the relationship looks like, if look closely, 1 upon t square is proportional to 1 upon L. It looks like the relationship is linear, but actually it is not linear. Okay, it is inverse relationship. Okay, and because of this quadratic function, this exactly is not inverse. Okay, there is some kind of, you can say, parabola or hyperbolic relationship between the two. Therefore we can say that this relationship is inverse, okay, not linear. And because of this square term that is associated with our time period, okay, this shape comes like a it will become coming with something like this. So we are going to have this as L, and this will be 1 upon t square. So next question. Okay, so it states that a rod of mass m, length L is hinged or pivoted at its center and can rotate freely about the hinge. Two balls collide with the rod and stick to it, perfect inelastic collision. The ball of mass 2m collides vertically downward with the speed v at a distance L by 2 from the center. The ball of the mass m collides vertically upward with the speed v at a distance L by 4 from the center. after the collision both balls stick to the rod. Find the ratio. This actually, this relationship is our capital V upon omega, okay, not small v. Okay. So here is capital V. So let me draw the basic figure that is given to us. So this is our rod, and suppose this is the point of the pivot, and we have a mass 2m traveling the velocity v, and it strikes at a distance of our L/4 from the center, and we are having a mass m. It moves upward with the same velocity v, and it strikes at a distance of L/2, and there is a perfect inelastic collision. So after, you can say, collision, they are going to stick with the rod. So you have to remember this part. And basically this is a you can say our angular momentum conservation. And so let us find out the respective angular momentum of both. So you can say that our angular momentum because there is no external force present, so angular momentum will be conserved, and we can say angular momentum about the hinge is conserved. And so let's find out the respective our angular momentum. So we have a mass 2m, and for that let us call this as L1, which will be equal to our 2 times m, and the lever arm is our L/4, and the velocity it is moving is our v. So this comes as our half m L v. And then we are having our mass m. Let us call this as our L2, and so this comes as m. It strikes at a distance of L/2. Velocity is our same, so this comes as our half m L v. Therefore, okay, and please remember this is just before the collision. So this is our initial. So you can see our total initial. Let us call this our Li will be equal to our, because the direction they are going to introduce will be same. So it will be our half and half plus. So this will L1 plus L2. This will be giving us ml times v. And then we come to our moment of inertia of our this rod about its center, and then we find out the respective mass also. So we come our moment of inertia, and first is our rod about the center. Which is our standard formula. We get this as I of the rod will be equal to 1 upon 12 ml square. And then we are having, because it is perfectly inelastic collision, so both masses are going to stick with it. then we get about 2m, and it is at a distance of L by 4. Therefore, we can write the moment of inertia because of this mass 2m will be equal to our basic formula, that is our mr square. So let me draw the figure here. So after collision, we are going to have this here mass 2m. It is going to stick here at the distance of L by 4, and this here mass of m, it is going to stick here, and that is a distance of L by 2. Okay. So the moment of inertia of the entire system will be equal to moment of inertia of the rod plus moment of inertia because of this 2m plus moment of inertia because of this m. Okay. So first we found out the moment of inertia of the rod about its center, which is a standard formula. Then the moment of inertia of this 2m, and for mass we already know the standard formula is about mr square for any mass. So it comes as about 2m, and this will be 2m, and r is the distance. The distance is about L by 4 whole square. So we get this our moment of inertia of the mass 2m will be equal to 1 by 8, and this is our ml square. And then we come to our mass of our m. So we can say moment of inertia of m will be equal to m, and this is at a distance of our L by 2 whole square. So we get our m will be equal to 1 by 4 ml square. So it means total final moment of inertia, let us call this IF, will be equal to moment of inertia of the rod plus moment of inertia because of mass 2m, moment of inertia because of mass m. So we get I final, this our ml square is our common, so we come this as our 112, 18 and 14. 112, 18, 14, and this comes as 11 upon 24 ml square. Now our momentum conservation, angular momentum conservation. So initial was our mlv, and final will be equal to our moment of inertia times our angular frequency. So we get this as 11 upon 24 ml square times omega, and this mass and mass length square goes away. So we get that our, what we have to find out, the ratio v upon omega. So you can say that our v upon omega will be equal to will be equal to 11L upon 24, and the length is given to us as 8. Therefore we can say that our v upon omega will be equal to 11 times 8 upon 24, which gives us 11 upon 3. Okay. So this was our relationship between the linear velocity and our angular velocity. Okay. Next question. It states that the work function of the metal surface is 264 into 10 to the minus 20 joules. The threshold frequency of the metal is x into 10 to the 15 hertz. Find the value of x. The Planck's constant is given to us. So this is quite easy. can say that our threshold frequency, we can just use our direct formula, that is our mu naught will be equal to work function divided by our this Planck's constant. So this is our 264 10 to the power minus 20, 6.6 into 10 to the power minus 34. Okay. And it is given in terms of our x, and so this will be coming as our 40 into 10 to the power 14. Okay. And we are given that this is our x into 10 to the power 15 hertz. So we can rewrite this as our 4 into 10 to the power 15. Therefore we can say that the value of x is equal to 4. So this was quite straightforward. Next question. It states that a gas undergoes a process in which its states change from 1 atm 60 ml 27 degree to p atm 30 ml and 77 degree. Find the value of p in atm. So for a fixed amount of gas, we can write this as P1 V1 upon T1 is equal to P2 V2 upon T2. For fixed amount of gas, we can write our P1 V1 upon T1 is equal to P2 V2 upon T2. Okay, and so we simply substitute value 1 atm 60 and temperature is our 300 Kelvin, P 30 and this is our 350. Therefore we get that our P, so here this 0 0 0 0 cancel out, so we get our P, and this will be going by 2 and this will be going by 15, this will be going by 7 and this will be going by 3. So P will be equal to 7.3 atm. Next question. This is basically statement type, assertion and reasoning. So it said work done by the force from R1 R2 is minus of this. It is not minus, it is always in terms of positive expressions there. So this expression is written incorrectly and it is our plus, and work done is a conservative force, that is also our, you can say, incorrect option. So both are false because this was our straightforward. And okay, so this completes all the, not all the, but some of the questions which was asked in the 22nd for morning session as well as evening section. I think we did close to 27 questions, 27 or 22, something like that. Okay, so this completes some of the question, and please remember these questions were memory based. Okay, so there might be some data here and there, some statements might be, you can say, not actual, but you just get the feel what type of paper was, questions were asked in the, for the 22nd morning as well as